Please understand the reason why I'm asking you to respond with this idea that I'm capable is because it doesn't matter what's happened in previous math classes. It doesn't even matter what happened yesterday. Every single one of you is capable of growing and learning. The reason why I teach, and I will point this out, does anyone remember what my undergraduate degree is in?
Engineering.
It was in civil engineering. Definitely could be making a whole lot more money than I am teaching. So why did I go on to become a teacher? Teaching high school geometry instead of something with engineering. Why am I here?
You care about us.
I'm here to help you, but not to make you capable. See, I need you to hear me clearly on this. I don't have to make you capable. You already are capable. Hey, I'm talking. You already are capable. I'm here because I want you to find how capable you are. I do. Like, I want you to find how capable you are. You are capable of amazing things. And now, I'm not just referring to mathematics. What's a skill that I'm trying to help you develop that you're going to need for the rest of your life? Anybody know? Critical thinking. Please hear me very clearly on this. I'm not teaching you math. I'm not just teaching you math. Let me clarify that. My job is not to just teach you math. My job is to help you learn how to think. And for the rest of your life, are you going to have to make claims and have evidence for those claims? Anybody remember what that's called? An argument, right? Like, that's the big thing, is I want you to understand how to develop arguments. Not meaning that you butt heads with people all the time and you argue with people all the time, but I want you to learn how to develop arguments, how to say, this is what I believe and here is why. Develop the evidence for that. Any other ideas about skills I'm trying to help you develop besides just thinking and argumentation? Any guesses? Nathan?
Real life situations or real life mathematics.
Some, but I mean, like right now, like the statistics stuff, 100%, right, data? But like right now, we're talking about corresponding angles, alternate interior angles. It can show up in real life, but how often do you think you're going to use that information in real life? It's possible, but not very often.
But also abbreviates.
Say again.
Abbreviates or however you say it.
Okay. Let me ask you this. Every single day, what are you supposed to do within your groups? Not just do math. You got to talk. You got to collaborate. Guys, I need y'all to hear me very clearly on this. Y'all aren't used to this because it's not what's traditionally been taught. But at the end of the day, you are going to have people in your lives every step of the way, whether you have a relationship already with them or not. And with those people in your lives, you're going to have to learn how to build relationships. You're going to have to learn to talk with people you don't know and figure out how to grow and learn together. That's why I have y'all in groups, right? That's an important skill to learn how to communicate with people. And I will bring this up because, and please understand, I'm not calling you out, but Joey said yesterday, like in the middle of class, right? I don't know them, right? It's hard to talk to somebody you don't even know their name, right? Yes? Yes. It's hard to talk with someone who you don't even know their name. Which is why, at the very beginning of the year, what were we supposed to create? Name cards. I'm not going to make you do it today because I'm already talking about this right now, but tomorrow up here is going to have directions that if you don't have your name card, to make one at the very beginning of class. There's free paper right here to make a new name card. There is probably more than enough for everybody in class. Right? So you're going to take this card and fold it in half. Make a name card because Joey's 100% right. It's hard to talk with someone you don't even know their name. But you need to know how to develop relationships with people. That's an important skill. And I'm going to try to teach you a little bit of math along the way. But you're here, or I'm here, because your education matters. And again, and Lillian even said it, like, how often are you going to use corresponding angles for the rest of your life?
No.
It's a possibility. But at the end of the day, what you will have to do is you will have to think. You will have to develop arguments. You will have to learn how to communicate with human beings. I'm trying to help you develop skills. I'm trying to help you be prepared for life after high school. So please trust me and do what I'm asking you to do. Jaden, I already asked you about the hood. Take it off, please. Okay. And once again, please hear me on this because I don't say this enough. If I get on to you, it's because I care about you. If I let you sit there and do nothing, I don't care whether you succeed or fail. I'm gonna because there's no way for you to be successful if you just sit there. I get on to you, I ask you to do work because I know that you're capable of amazing things and I want you to find that success. I need you to do what I ask you to do. I need eyes up right now. When I'm at the front of the room, right, to engage, you need to be looking at me, right? In small group time, what do you need to do to be successful in my class? You've got to talk with each other. And again, do you have to know the perfect answer? No. But I need you to talk about the math, and then we will come together and have a whole class discussion. During the whole class discussion, what do you need to be doing? You got to ask questions, you got to engage, you got to share ideas. You also need to be taking what? Notes. Those are the things that are on the active collaboration rubric. You do those things, one, your active collaboration score will increase, which increases your grade, but also if you're doing those things, you're going to learn more. Talk more. Ask more questions. Take some notes. Engage in the classroom. I promise you, it'll make the class more interesting. Now, let's look at this bell ringer before we get started. Nope, that's not the bell ringer. Here it is. Stopping the poll, looking here. So explain how to recognize corresponding angles. Angles are the number of sides corresponding on the same line. They look similar to the same. Ooh, so this is how I know that we need to talk about this a little bit. Okay. So here's the thing, and I've talked about this before. Mathematics is the study of what? Patterns and relationships, right? Like that's how I know you can be successful, because I know every single one of you can find patterns and relationships. The tough part of math comes in when we need a common what to talk about the patterns and relationships. Language. It's tough, right? But we need a common language, and we need to be precise with our language, and we're not used to being precise with our language. But if you're trying to talk with someone, and you're talking about the same thing but using different words, can't that make it pretty difficult to actually communicate? Right?
Yeah.
Yeah? Like if you talk to someone who's from, let's say that you want to have, I don't know how else to say it, a Coke, right? If you want to have a Coke, right, that you want a Coke. But if you talk to someone from like California or the Midwest, you know what they're going to say? Because they're not going to call it a Coke.
A soft drink.
They're going to call it a
New
pop.
Orleans call it a cold drink.
But when I hear the word pop, I think of like a popsicle. I don't think of Coke. So could that lead to confusion?
But no,
Yes.
But like, if you ask for a Coke, ain't that what the brand is called? So if you ask it from somebody from a different state, just say I want a Coke.
But Southerners talk about Coke as like every type of soda, right? Like we do. Like I've heard people say like, okay, I want a Coke. Okay, what type of Coke? I've literally heard that question afterwards, because people just say Coke all the time, and some people call it soda, some people call it pop, some people call it other things. And so we need to be aware of that. And that's my point here with this math. If we're trying to communicate and talk about these things to find success with each other, we have to develop a common language, and we have to be working towards that end. Okay, so we're going to talk about the answers in just a second. What we're going to do today, agenda-wise, lesson 2, hip to be square. I need y'all to hear me on this very clearly, because I know this is going to sound super nerdy. But I worked through this lesson, because I haven't taught geometry very much over the years. This is actually only the second time I've taught geometry since I was 22, so almost 10 years ago. Okay? But I'm starting to learn, and I'm getting better at it. So I work through these lessons before I teach it to you to make sure I understand what's happening. Right? I take that time to be prepared. I worked through this lesson. And any guesses what we're going to be trying to create by the end of this?
Square.
A square. Y'all, I used the tools in this book that they would ask us to use to create a square, and literally I went through and I checked my angles and I checked my sides, and guess what I created? A square. It felt so cool, and I know that sounds nerdy, but it felt so cool to actually create a perfect square with all right angles and all the same length sides. Like, it was exact. It was the coolest thing. And you can find that success too, and I know it's nerdy. Jaden's looking at me like, Mr. Kinney, that's cuckoo for Cocoa Puffs, or Jordan, not Jaden, sorry. Jordan's looking at me like I'm crazy, right? But it's true. Like when you find success with things and you create something, it feels awesome. So let's engage in this. Trent, it's hard to engage in this when you already got your head down. Come on, head up. All right. So we're gonna look at these squares. And so, yes, sir.
I kind of do got a question though. Do you think that math is the most important subject? Because now that I'm thinking about it, because I sat there and actually thought about it, language, like letters is in math, now we got shapes in math, we got a bunch of stuff in math, but I don't ever see like shapes having nothing to do with math. I mean, shapes, math having anything to do with shapes, but now what? Do you think math is the most important subject?
I think this is something to be aware of, I think that learning how to learn is the most important thing out of school. Not just learning any one subject. Every subject has its own value. Like if we talk about history, why do we study history?
So you can know about the past.
So that what?
For the path doesn't repeat.
Joey, someone else was talking. I'll let you say something in a second. But Lily, what were you saying first? Okay, so we don't repeat what we already did. Like just think about the U.S. What are some issues in the United States that we should probably make sure we never have happen again?
Slavery.
Slavery,
Okay,
World War I. Now that's an international issue, right? So slavery is a legitimate issue, right? We don't want that coming back on us, right? Okay, we probably want to learn from. Excuse me, we're having a whole class discussion, not small discussions. We probably don't want the Great Depression again. We don't want to allow the same economic policies that allowed our economy to collapse, right? That's probably pretty fair. We probably don't want another Cold War with Russia. We're going to do what we can to avoid that now. But the reality is that we're always going to have issues, but if we can learn from the past issues, then we'll be able to improve. Okay, so what about English? What do we learn from English? Language, communication, right? Learning how to read, learning how to analyze stuff that's been written. That's useful in life. One of the things I will say about this, math is the study of what again? Patterns and relationships. So yeah, let's take away shapes and everything else. Will you have patterns and relationships that show up throughout your life, Jordan? Yeah. Is it important that we learn how to analyze not a specific pattern, but patterns in general and be able to talk about those things and communicate the things that we've learned? Yes. So is math going to be useful in that way? 100%, right? So there's that part of it. But also I'll say, I've already said math is a language. Do you want to know one of the places that math is most heavily used all the time?
Greece. They be doing code and armies and stuff like that.
Science.
Math part 2.
Okay? Science is math part 2, is that what you said? And that's true, right? All that science is again finding patterns and relationships in the natural world and putting a language to that. And we got to use math for that. So it's not about any one thing. Your education matters because it helps you appreciate the world around you and because it helps you learn how to think and work with other people, right? So there's a lot. I would never say one subject is more important than another. Okay? Oh, here's the thing I do want to point out. In order to have a square, what has to be true about the sides? They all have to be what? The same. So we need to learn how to create line segments that have the same length. And what do we need to have true about adjacent sides? They need to be
Next to each other.
yes, but in a square, those adjacent sides also have to be
Right?
They have to be. What's the term that
Perpendicular.
They have to be perpendicular. So what we're going to learn heavily out of this lesson today is how to create perpendicular lines. If we're going to make a square, we got to learn how to make perpendicular lines, and not just by taking a ruler and drawing along it. We're going to talk about perpendicular lines more heavily today. So we drew right angles. A lot of us got close because a lot of us just took the ruler and made sure that we drew along the edge there. But we need to learn how to actually, yes sir?
What was them things for yesterday?
We're getting to it today. We just didn't get there. Yep. Okay. So there we go. And notice, what were those things that Thomas is referring to? The compasses. We're going to get to those compasses more heavily today and actually use them a good bit. And so we're going to learn how to construct geometric figures. When we say construct, that means that we are going to do what?
Build it.
We're going to build it. We're going to draw it, meaning that we're going to be precise. I think you referred to that yesterday, right, Lillian? So we got to learn how to be precise with our drawings. We're not just sketching things anymore. So here is activity 2.1. This is on page, I don't remember. M1-19, thank you. Go ahead and make sure you're looking there because again, it's hard to grow and learn if you're not even looking at the pages. M1-19, it's a good day to learn, right, Keandre?
Yeah.
That's what I like to hear. Okay, so we have this activity 2.1 here. And one of the first things that we need to recognize is this right here. What is this called? Okay, so actually, I'm really glad y'all brought this up. This is not called a graph. Okay? This in orange would be a graph. Okay? The graph would be the function that you draw on there. Look at the very first sentence at the top. What is this called? It's called a coordinate plane. Right here at the top, Joey. You know that a coordinate plane. That's what we're talking about. Okay? It's called a coordinate plane. That's something, again, if you weren't sure of that wording, that's the language you'll hear me use. It is a coordinate plane with intersecting lines, the x-axis and the y-axis. That's what creates the grid. Alright? You can also think of a coordinate plane as being composed of squares. Notice everywhere, once you look at the grid, what is making up everything in that coordinate plane?
Squares.
Squares. So you know what's going to be really important for geometry? Squares. Say again.
Graph paper.
Okay, right, but listen to the question again, or a question I said again. What is everything on here made up of? Squares. So what's going to be really important for geometry? Squares. If you didn't hear me the first time, squares, okay? We got to understand squares really well, right, Jaden? You awake over there, my man? There we go, get the head up. Come on, dude. All right, so we're going to learn how to create those squares. Here's the very first thing, all right? So we're going to take some patty paper, and notice right here it says, let's start by experimenting with patty paper to construct a line perpendicular to a line segment. So draw a line segment on a piece of patty paper, which I'm going to pass this out. 1, 2, 3, 4. Once I get the patty paper to you, follow the directions on the paper. Now I want you to hear me very clearly on this. If you do not have thick lead, like a 0.9 or 0.7 lead, it's not going to draw very well. You can get a pencil from up there, or I will let you borrow one of these pencils. You need a thicker piece of lead, okay? Please make sure you give it back to me because I only have so much money and we have not gotten any school money yet. In fact, I already had to spend close to $100 for this classroom this year. Huh? 0.9 or 0.7. Okay? You can also use those short pencils. All right, follow the directions in the book. Let's work through that worked example. Yes, sir. Yes, sir. Yeah. Yes, sir. Millimeter pencil. What kind of pencil do you have? You have a wooden pencil. You're good. Please make sure you get these back. Come on, guys. Let's get seated. Let's get to work. Jordan, I already threw you a pencil. I know. I'm getting out some more for the next thing we do. Okay? So follow the directions on the worked example. It tells you exactly what to do. Oh, actually, I just realized this. Hey, I see some of us just kind of sketching a line segment. Please listen. How do you know for sure that it's a nice straight line? Say again. We might want a ruler. One person per group. Go get rulers for your group to make sure that you have a straight edge. Okay. Come on, listen. I need you to do it. Oh, sorry. I forgot to tell you. I put the rulers and everything else on the back counter so it'll be easier for us to grab. That would have been helpful. So when you do the ruler, make sure you make it a straight line, okay? And did you follow the directions from the book yet, Joey?
I want to start, right? Golly.
Not yet. Just grab rulers for now, y'all.
Bro, these are the last four.
I know, use that ruler though. Okay, no, you already have the piece of paper there, Keanu. Because we're about to use some more paper on a different problem. Yep. You want a different sheet? Jordan, get to your group. You ain't that slick. Follow the directions in the words example. I know y'all can read, and if you can't read, talk with a group member, see if they can help you out. Did you follow the directions? Right there. Work example. Have you followed the directions yet? Come on.
Wait, mine is like like, why you don't like it? There we go.
All right. So, hopefully we've gotten there. It shouldn't take us terribly long. Notice it tells us to fold the line segment so that it lies on top of itself. Right? So, we should be able to easily see that line segment there. I fold it over just to make sure that I can see the line segment on top of itself. I fold it nice and hard. I get that nice crease in there. And when I unfold it, what is true about that crease? Anybody? What's true about that crease? It's not uneven.
It's in the middle.
Okay, do this for me, if we weren't sure. Can you let Caitlin in, Ezra?
Okay.
Once you have that crease in there, take a ruler and draw a line along that crease. No, there's paper literally on your desk already. Okay, so you might not be able to tell, but I drew a line along that crease. One person per group, go and grab a protractor. I want you to measure the angle of that line that was created. Use this to go along your crease. Use your straight edge to draw along that crease.
Hey, Miss Ken.
You don't want to cooperate.
What is a protractor?
Look.
Read the directions in the book. What does it say? Thank you. Fold it over so that the line is on top of the line. Look at that. Look at that. Huh? So what I said was, take your ruler, right? And I'm just saying, draw now a line along that crease. Right? Because I want you to see something. What is true about the line created by, it's hard to see there. What looks to be true about those two lines?
Where's the rule?
So we want to try to go like all the way around.
That's fine if you do. I mean, I can't see your line. You need to make that. Make this darker.
Oh, like this.
Right here. There we go. Fold it. So it's right on top. See how that's right on top of there?
Why would you call up my paper? Can I get a new paper?
There's already paper on your desk. Okay?
It got
No, just that's fine. That's not a major part of the instruction. Okay, for those of us who got there, listen, because you're gonna get another practice with this in a second. Eyes up here. Hey guys, when I get to the front and I ask y'all to pay attention at that point. I know you're still working on stuff. You're gonna get a chance to do another one of these in a second. Did anyone figure out what was true about the crease and the original line? What? It was perpendicular. How'd you know? Not well. If I were to actually look at it in a second, just because those lines intersect does not mean they're perpendicular. For example,
0 equals for checkout.
he's on his way. Ezra, they need you for checkout. So pack up your stuff. Right here, guys. Hey, look. These lines are intersecting, right? Yeah, Andre, are these perpendicular?
Yeah.
Yeah? Do you know what I mean by perpendicular? It's okay if you don't know, just ask. Is that where the confusion is? Huh? Okay, so what does it mean for lines to be perpendicular? Okay, so if lines are perpendicular, they intersect at 90-degree angles, right? What do y'all think? Do those look like they're 90 degrees? No. But when you look here, do they look 90 degrees?
Yes.
Did someone check to see if they're actually 90 degrees?
Yeah.
They were, Emily? Yes, they were, Joey? It was? So, when we fold that paper on top like this, boom, it created a perpendicular line or line segment. See you, Ezra. And notice I will point this out because y'all made this way too hard. What does it say right here?
Over the paper.
The crease represents?
line.
Oh, perpendicular to the given line
I
segment.
got you right here.
Okay,
Guys.
guys, well, here's the thing. Listen, a lot of times we struggle with things because we just don't read the directions. Slow down and read the directions. Like, there's a reason why it's there. This information, a lot of you would probably skip, but don't. What is this telling us the difference between?
A line segment, and a point.
Do you think those things might be important?
In geometry, yeah.
In geometry, very much so. Anytime something is bolded in the textbook, that is a key word that you need to define. So a line is described as a straight, continuous arrangement of an infinite number of points. Have you ever thought about a line as infinitely many points? Emily, are you saying no?
Maybe not before this class.
Okay, have I mentioned that in this class though?
Yeah.
Okay, I thought I had. It was when we did the regression lines, right?
I was just saying, like, I don't sit at home and think that. Like,
Well, you were supposed to have been taught that at some point, right, in middle school. Most of us, unfortunately, were not. Okay, so listen, all right? We are looking at the idea of a line being the infinitely many points. So what's the difference between a line and a line segment?
It's just a section.
Just a section, right? Is this a line segment?
Yeah.
No.
No.
How do you know that this is a line and not a line
Oh, the
segment?
arrows.
The arrows. Remember, the line is infinite long. It never stops, right? So a ray is when it has one endpoint and it continues forever in one direction.
Oh, it looks like a literal arrow, like triangle, but.
But that's a ray. We go with that. Whereas a line segment has two what?
Point.
Endpoints. All right, we go with that idea, having two endpoints there. So notice it says a line segment is a part of a line between 2 points on the line called the endpoint. We can have, now we'll point this out, can you have a distance for a line or how long the line is?
Yeah.
For a line?
No.
I heard someone say no. Why not? Why are you thinking no? Say that one more time. A line never stops. Can you measure something that never stops?
You just put it as infinite.
But can you measure it? Can you put a ruler to it and measure how long it is? So we can't measure something that never stops. A line you cannot measure, but can you grab a ruler and measure this line segment? 100% yes. That's why we're going to study lines short. We're also going to study line segments a whole lot. Notice a point is just a what? Location. That's what a point is at its core. And I will point this out, right? I draw my points really big, but did you know that points aren't actually that big?
No, they're like very small.
They're actually so small that you can't even see them. That's a point. And if I could, I could make it even smaller and it would still be a point. A point is just a location of something. We typically make it pretty large so that you can see it. But a point is actually really, really, really small.
Smaller than an atom?
It is, well, yes.
Wow, that's really.
I know, right? So that's how, notice like there's a line segment here, but do you know how many points are along this line segment?
A lot.
Not just a lot,
Millions.
not just millions.
Billions.
Say it again. Infinitely many. I know that sounds wild because there's infinitely many in this line, but also in this line segment, remember, yeah, that's a point, but here's also a point, right? Can I get a point in between those?
Yeah.
Can I technically get a point in between those?
Yeah.
And they start to overlap, but technically, that's only because I'm drawing them as big as I am. I can make them smaller and smaller and always get in between. There's infinitely many, even on a line segment. And I know I'm the nerd in the room saying this, but that's kind of cool. Anyways, alright? Yep, I know I'm a nerd. Alright, so here's what I want us to do with line segment AB. I'll go ahead and tell you, some of you have already done this, but copy AB onto the extra sheet of patty paper. If you don't have enough patty paper, let me know. But, pause. Hey guys, hold on. Listen to directions first. Listen to directions first. Stop and listen, okay? Use patty paper to construct two different perpendicular lines through AB. And then part B says, how can you fold the patty paper so that the perpendicular line or perpendicular crease intersects the midpoint? So two things I want to talk about. Take a fresh sheet of patty paper and literally just copy, trace over that line segment. And put the endpoints at the right place. Does that make sense? Okay? You're going to create how many perpendicular lines? 2. Now, here's a key term that we have to know. Right here, it's talking about the midpoint. What do we mean by the midpoint?
Middle.
It's in the middle, meaning what? So if this is in the middle, and it's not perfect, that might be close. That's a little off. Maybe here's the middle. And this is why we want to develop this skill, is to learn how to get the midpoint. What's true about either side?
They're equal.
So I'm cutting this in half. If you have the midpoint, we want to try to cut that segment in half. Follow the directions, complete number 1, parts A and B. Alright, complete parts A and B. Ethan, we're on the next page, but say again. Yeah. Hey guys, this is on the next page. If that wasn't clear, we're on page 20. You're tracing line segment AB. You can use a ruler to help you trace it. What's going on? Are you doing Hold it on top of each other. Did you check? So I put that in the center. I make sure that's all 0. Looks like 90 degrees today. Now I need you to follow the directions on page 20.
Wait, take the rule out.
Joe, have you done number 1 here? Joe, have you done this number 1 yet? Huh? What is this? That's the patty paper on there. Come on, let's try it. Have you completed? Where's your line segment AB? Come on. So, how did you, that's your answer for 1B? Okay, did you do 1A yet? I will point this out. I can already tell it's not perfect. Do you see why? What's wrong? See how they're not on top of each other? You need to try that again. It's going to be pretty darn close, but try it again. You know we're doing AB, right? Oh, you haven't traced AB. Guys, pause and listen. Where is AB on page 20?
At the top.
At the top left. Trace AB onto your patty paper. And let's complete it. Trace AB onto your patty paper. You're capable of amazing things, but you're not setting yourself up for success. What's the issue? That's AB? Yeah. Now have you followed the next set of directions? Part A and B. You have to get your perpendicular line segments. How should you do this problem? I'm going to learn any of this. Just on here?
It's on the crease.
What is it? What is the problem that you do? Okay. Hey guys, let's clarify. I need y'all's attention up here. Please note, I'm not asking you to make two lines that are perpendicular to each other. We're trying to make two lines that are perpendicular to AB. What can we do to make lines that are perpendicular to this line segment? When I fold it, what do I want to see?
You put a hot dog.
Okay, but what do I want to see? Well, I want the line segments to overlap, right? So when you fold it over, that line segment should overlap each other just like you did on the worked example. There you go. Okay. It should fold over on top of itself. Have you already done 1B? So make sure you write about it here though, so that you have notes to refer to. But you didn't just, because remember when we folded earlier, right? Well, how did you fold earlier? Okay, so you just folded on top of it. But I will point this out. If you fold like this, right? See how I folded on top of itself? Is that perpendicular to this line? Huh? You sure about that? But it didn't go through the midpoint. As long as the line segment folds on top of itself, it will be perpendicular. So you need to know the difference between A and B.
Basically, we just say, fold the paper so it can overlap. So you can have perpendicular lines. I'm not getting the
Then I try to.
I gotta read it.
You can still do it with just that. It'll be okay. But we have a whole class conversation about this.
Fold the paper. They gotta overlap. I don't know if that line in the middle is, but don't ever run. So it can overlap. You gotta fold the middle line. Yeah.
Thank you. Thank you. Thank you. Okay, so really quickly, I do want your attention on this because I'm realizing while talking with you, and so hear me clearly on this. One of the reasons why, is this one I was using earlier? Yes. Okay, one of the reasons why, sure. I'm not sure either. I think that was the one I used. One of the reasons why I have you work in your small groups is so that I can hear your ideas and figure out where you are making mistakes. I want you to see clearly here. Do you see this line that I drew through the crease? Is that going through the midpoint? Nope. Is it still perpendicular though? If you check that angle measure, it's still making 90 degrees. And so some of us were already automatically finding the midpoint. But please note, if they fold over on top of each other, the lines, right? This will still be what kind of line? Lines here. Perpendicular. So if I fold all the way over here, and I make sure, Joey, your eyes up here, buddy? Sorry, you're just in my view. I'm talking about stuff. Come on, Joey. Come on, Joey. Come on, Joey. I know you're capable. These are still overlapping, right? So when I unfold it, what should the crease be to the line segment? Perpendicular. And if I check that angle, it will be perpendicular. But that's all we need to recognize here. How are we going to use patty paper to construct two different perpendicular lines? Fold. So the line is what? Well,
Exactly.
the drawn line needs to be what?
On top of each other.
On top of itself. It doesn't matter if the whole thing overlaps. Just fold so the line is on top of itself.
You write that down?
Is that right on board? Come on, man. Yes. What? What? It's okay. I need you paying attention to this. We'll get some more practice in. Okay. Taylor, you got all that down?
Oh, where's my pencil?
So 1B is a little bit different though. What needs to happen so I get the midpoint? Not only do I need to fold over, some of y'all already discovered it. What else do I need to do to get to the midpoint? Not fold it twice. I've seen. Say again.
90-degree angle.
Well, that's just, is that, so the idea of 90-degree angles, is that the midpoint? Nope. I want y'all, I know some of y'all have already done this. What would I need to do when folding to get the midpoint here? The line needs to be on top of the line, but something else needs to be on top of itself. If I put those endpoints on top of itself, then these two segments will be how long? Or their lengths will be what?
Equal.
Equal, the same? So if I have the midpoint, what are these two lengths here? So they are the same, right? So if I fold and I get those points on top of each other, right? I now have my midpoint. I know it might be hard to see, but I want you to notice, does that look like I found the midpoint there? Does that look like the midpoint? Yeah? Does that look like a midpoint? Right here? Does that look like it's in the middle? Yes. So what should we say here for 1B? How are we going to get to the midpoint with that patty paper?
In the middle.
Oh, okay, yeah.
Okay, so when we fold, the lines need to be on top of each other, and so do the endpoints. I will say this, here's an important word. Instead of saying on top of each other, the mathematical term for that starts with an M. I think I've mentioned it before. Maybe not. They need to map. So when folding, the lines and endpoints need to map to each other. I'll throw this way because imagine that's a little hard to see. That's 1B. So when folding, the lines and endpoints need to map to each other to get what? To find the midpoint. Okay, man, that marker's not great either. So when folding the lines and endpoints, when folding, golly, I should have put a comma here. Make sure you put that comma, because it's when folding, the lines and endpoints need to map to each other to find the midpoint, right? So, introductory phrase. So when folding, the lines and endpoints need to map to each other. And so what's a way to kind of think about them mapping to each other? How would you normally say that? They're folding on top of each other. It's not quite on top. It's this idea of mapping, but that's how you would typically think about it. What are your questions about 1A and 1B? I'm going to move on if there's no questions. Thank you, Tori. Alright, so we're looking at 2 now. Thomas determined the midpoint of a line segment incorrectly. Explain what he did. You don't have to have the right answer, but I do need you to take the next 60 seconds to talk with your small group and figure out what Thomas might have done. Actively collaborate to generate some ideas that we're going to have a whole class discussion about. What did Thomas do that was incorrect to find that midpoint? Have we used a protractor at all for any of this? What have we been doing this whole time? Look at it. Hey, oh, sorry. Really quickly, if I grab your attention, one thing to clarify, what do you think that dashed line is? That's his fold. If you see dashed lines like that, that's his fold. Use that information as you're trying to figure out what Thomas did wrong. I don't have enough for everybody. I'm trying to make do with what I got. Do all y'all already have one?
Yes.
Yes. I have to borrow them. Do you already take? You don't have one of these, right? You do. It's perfect. Okay. Yes, sir. I don't have enough for everyone to have one. We're gonna talk. We're gonna work with it. Stay calm. Okay. If I can grab everyone's attention. So, anybody have an idea? Please remember, you had a small group discussion. Now this whole class discussion is part of your active collaboration. What did Thomas do incorrectly? Raise your hand if you have an idea. Alright, so let's give Taylor a chance to say something. What you got?
Taylor.
I thought you had your hand up.
When he folded it, it wasn't even.
Okay, so when he folded it, it wasn't even. Alright. Jordan, you want a shot?
She wants a shot.
I'll let her talk in a second then. Addison, what you think?
We also said that he didn't like the line straight.
Say that one more time.
He didn't like the line straight.
Okay, so he should have had his line straight across like this. I will say this though, even with a line at an angle, he still could have found the midpoint. Okay, so what could he have done? What did he do incorrectly? Maddie?
His endpoints do not map each other.
Oh. If you map your endpoints to each other, what will you have? You will have the midpoint. If you map your points to each other, you will have the midpoint. What does it look like he actually did?
Folded.
He did fold, but how did he fold? He
Folded.
folded the paper in half. Isn't that right down the middle of the paper? Were you supposed to just fold the paper in half willy-nilly? No, when you want a midpoint, you need to fold the endpoint to the other endpoint. So he folded the paper in half. Hey Jaden, you taking notes on this, my man? It looks like you're playing with that ruler and that protractor. No, dude, you have paper or pencil. Don't use the protractor or the compass for that. All right, he folded the paper in half, but what should he have done?
Put his points in.
Should have folded the line in half. And how are we going to do that, though?
Putting the points in.
So what's the more mathematical term for that? So we're going to map the endpoints. All right, but he should have mapped the endpoints. Alright? You can't just willy-nilly fold that paper in half. You gotta map those endpoints. Okay? Alright. So looking at number 3 is actually going to ask us to bisect ST, or line segment ST. And so what I will point out is this. First off, what does it mean to bisect a line? Or not a line, a line segment. Not to go past it. Say again. Okay, so maybe make 2 lines. Okay. Let's look at the information given to us under number 3. What does it say a bisector is?
Line
Wait, so if I have cut this so that I have 2 line segments of equal length, what do I have to have found? The midpoint? Do you know how to find the midpoint now?
No.
Yes.
Joey, we just spent like 10-15 minutes on it, my guy. Joey, you can't be sleeping and then just randomly say things.
I was awake when you went over it.
Okay, so pick up the padding paper you've already been using, or a different piece. If you need one more piece, raise your hand, I'll bring some around. But, excuse me, I'm still giving directions. Hands down, stop moving, stop talking, stop. Okay? Guys, y'all got silence your phone. I'll go take care of it in a second. Stop. Joey, if I'm talking, it's not time for you to shout out like that. So, when you get your patty paper, you again need to trace line segment ST onto this patty paper. And then get the midline so that you can have a segment bisector, or find a segment bisector to it. So who needed paper? Did you need paper? Okay. Once you get the patty paper, find that segment bisector. You gonna try? If you're not going to try, I don't need to give you waste paper. Okay, well, I tried to teach it. Talk with your small group. I'll come back and check on you later.
Just have to put our endpoints in.
I mean, think about what we've already learned. Use what you've been finding to help you find a segment bisector.
Any other way.
What? Did you find your second bisector? So here's the question for you, right? Saying that's it? How can you get that to on here? Any guesses? No, just that. Can't you put this back on top here? If you draw a point here, and a point up here, and then draw a line segment between them. Would that give you the second bisector? See what we did? So, so one thing I'll point out is what I was talking about the other group. Now, if we take this, what we want to do now is get a segment bisector on the ST. How are we going to get that onto this paper? Maybe. What are you going to do with the ruler? That's possible. It would be nice if there was an easier way, right? Didn't you get this line by... Was it here? Was it this one? Was that one? Okay. Is there a way to, I don't know, get this line somehow onto the page? I was just going to say... Let's do this. Here's a point on that line. Here's a point on that It's not necessarily what I would have done, but because there's a metal taper, just so you had to. Thank you. Thank you. So, here's my ST. I think a lot of us already know exactly what to do to get the midpoint because it's bigger on the board than it is in your book. Right? You're freaking out for the wrong reasons. Okay, so how am I going to get the midpoint of this line? The line segment, huh? Fold it. Fold it, okay? When I fold it, I need to make sure that what? That the endpoints are on top? Hey, do those endpoints look like on the top? Yep. Alright, so I fold it. And I now have my midpoint right there.
Why is it split?
Well, because I couldn't go across because how big mine is. But regardless, remember, it doesn't matter as long as I map my endpoints, I'm good. Now, I showed a trick over there to that group, but I do want to point this out. This right here is my, right here's my midpoint. This is perpendicular, right? And what we want is to now get the bisector of ST. Well, we can do that just using this caddy paper. Where did my pencil go? I have no idea. There it is. Found it. Nope, that's a pen. Here's 1 or 2 or 3. Okay. With this is going to seem really goofy at first, but can I take this pencil and, I don't know, poke through the midpoint right here? Okay, so I'm going to poke through at the midpoint. Now, can I mark the midpoint on that sheet right there? Mark your midpoint.
What's the midpoint? None.
Okay? I got my midpoint now, right? So, Devin, this would be the better way to do what I was showing you, okay? So you actually poke a hole through. Now, how many points do I need, though, to make a line? You need 2, right? So could I poke another hole through this bisector and put it up here and draw a line through it? Yes, okay, so poke another hole in your paper along the bisector, right? So I'm going to poke a hole through that bisector. Remember, that's the crease, my guy. Anywhere on the crease. The crease is the bisector. Anywhere on the crease.